In this video, we are going to discuss about circuit elements in electrical engineering. An electrical network is constructed from series and parallel combination of two terminal circuit elements. Circuit elements are broadly classified into two categories, namely active circuit elements and passive circuit elements. This video is fully focused on active circuit elements. What is an active circuit elements? An elements which generate or produce electrical energy are called active circuit elements. That means active circuit elements are capable of supplying energy to the network. Examples of active circuit elements are voltage and current sources, that is voltage source, current source, batteries, generators, it may be AC generator or DC generator, and electronic devices like transistors, field effect transistors, that is FETs, op-amp, etc. Among these active circuit elements, the most common active circuit elements are voltage source and current sources. The voltage source or current sources may be of two kinds. It may be independent sources or dependent sources. What is a dependent source? Voltage or current depends on either voltage drop or current occurring somewhere else in the network. The value of the voltage source depends on either voltage drop occurs somewhere else in the circuit or current flowing through the circuit. Such type of sources are known as dependent sources. So dependent sources may be dependent voltage sources or dependent current sources. We can learn these things in detail in proceeding part of this video. In the case of independent sources, output characteristics of the sources are not depends on any network variable such as current or voltages. But in the case of dependent sources, the value of the voltage source depends either the voltage occurs some part of the circuit or current flowing through some part of the circuit. And similarly in the case of dependent current sources. First of all, let's see independent sources. Among that, first of all, let's consider voltage sources. These voltage sources may be of two kinds, ideal voltage source or practical voltage source. What is an ideal voltage source? It can be represented in this way. So in the case of ideal voltage source, it maintains constant terminal voltage irrespective of the terminal current. Here the voltage source value is V and terminal current is I. So the voltage across these two terminals, that is represented by Vt with this polarity, the value of Vt is not depends on this I of t. So this is the Vi characteristics of an ideal voltage source. As It is increasing, there is no change for V. This voltage is maintained constant irrespective of the value of terminal current I of t. So an ideal voltage source is the one in which the voltage across the terminal is independent on the current supplied by the source. And this is the representation of ideal voltage source, and this is the Vi characteristics of ideal voltage source. However, in conventional voltage source, as the terminal current increases, there is a slight reduction in terminal voltage Vt. So it is denoted by this. As I of t is increasing, terminal current is increasing, there is a slight reduction in terminal voltage. So in a practical voltage source, the terminal voltage decreases as the current supplied by the source increases. So based on this relation, a practical voltage source can be represented by an ideal voltage source in series with a resistance R. So that terminal voltage Vt is equal to V minus I of t into R. So as I increases, terminal current increases, this drop increases. So the net voltage, the net terminal voltage reduces as observed in this diagram VI characteristics. Here R indicate internal resistance of the voltage source. Next, let's see independent current sources. Again, independent current source may be of two kinds, ideal and practical. In the case of ideal independent current source, it maintains constant currents irrespective of the terminal voltage. If terminal voltage is increasing, that factor is not depends on the value of I of t. If this value is I, that value is maintained constant as the terminal voltage is increasing. This VI characteristic can be represented in these two ways, either this or this. Here we can see that as V of t is increasing, the current is maintained constant in the case of ideal current source. Thus, an ideal current source is a two-terminal circuit element which maintains a constant current I of t, say I, flowing through its terminals independent on the terminal voltage. But in practical scenario, this won't occur. This situation won't come into picture. As terminal voltage increases, there is a slight reduction in terminal current supplied by the source. As terminal voltage increases, there is a slight reduction in this current. This behavior can be explained by connecting a resistance R in parallel with an ideal current source like this. We can write down the expression for the terminal current I of t as this current, source current I of t, minus the current flowing through this resistor R. Current flowing through R is the voltage across this resistor, that is V of t divided by R. A practical current source can be represented by an ideal current source in parallel with a resistance. In the case of practical current source, the terminal current is not constant. As voltage increases, terminal current decreases as shown here. As voltage increases, current is decreasing as denoted by this dotted line. As I mentioned earlier, the sources may be of two kinds, dependent sources and independent sources. In a dependent source, the voltage or current depends on the value of voltage drop or current flowing through some part of the circuit. The dependent sources are of four kinds, depending on whether the control variable is voltage or current. The first category is VCVS, that is voltage controlled voltage source. It is denoted by this symbol, a diamond symbol with polarity plus and minus. If polarity plus and minus is there, it indicates voltage source. If arrow is there like this, then that indicates a controlled current source. Which is controlling, that is denoted here. Here it is a voltage source. The value of this voltage source depends on the voltage across the elements X. So V is equal to A into Vx, where A is a constant scalar quantity. Vx is the voltage across elements X. So by varying the value of Vx, this voltage source value is varying. So that's why it is termed as voltage controlled voltage source. Similarly, the voltage source may be controlled by current flowing through the elements X. That is, the value of this voltage source depends on the value of current flowing through elements X in the circuit. So that into a scaling factor constant that determines this value, voltage source value. Since it is controlled, this value of this voltage source is controlled by current flowing through somewhere else in the circuit. That's why this is known as current controlled voltage source. And next two things are controllable current source. If this value is, the value of this current source is determined or fixed by varying the voltage across an element X in the circuit, then that is voltage controlled current source. It is a current source. The value of this current source is determined or controlled by varying the voltage across Xth element. So I is equal to C into Vx, where C is a constant. Similarly, in the case of current controlled current source, the value of this current source is depends on the value of current flowing through Xth element. So the value of this current source is I, that is equal to D into Ix, where D is a constant.